Hi, folks. This is activity number 2 in lab number 8, which is on March 7, 2023. Uh, this block is inserted into these two pins so that the pins are symmetrically positioned with respect to the block. And the bottom two faces of the two faces of the bottom pin are clamped, and the side faces of the top pin, both faces are being pulled up by a hundredth of an inch. Now, the question is, first of all, uh, what kind of elements you're going to be using at this point. I'm expecting you to use solid elements for both the pin and the block. And also, uh, notice that under the conditions stated, the bottom two end faces are clamped and the top two end faces are pushed up. There are two planes of symmetry. One is through the thickness of the block, halfway through the thickness of the block, and the other one vertically along the middle plane of the block, which obviously is going to go through the pins also. So in the class, I discussed a situation where there is a third plane of symmetry, but not in this case, because in this case, the bottom two end faces are treated differently than the top two faces. But in the event that you took the bottom two faces and pulled it down by a tenth of an inch, hundredth of an inch, and the top two faces of the pin up by a hundredth of an inch, then of course there will be a middle plane of symmetry and there will be three of them. But in this problem, there is only two. Okay, so I'm going to do this thing by through the top-down approach. In other words, within the product, I'll create all the parts, and we do the end. And then I'm going to split it. Okay, it is up to you whether you want to create the portions of the model that are needed. If you know there are two planes of symmetry, so you can start modeling this whole thing based on those two planes of symmetry, or you can model the whole thing and then use a split in, for example, the product design to split these parts simultaneously. That's what I'm going to do. Okay, so let's go ahead here and start with the product file. Because it's an assembly, we're going to do the product. There we are, and immediately I'm going to save this thing. So file, save management, save as. Now let me go to my folder, which was on the desktop, and this folder do not delete. Activity lab number 8, activity number 2. So I'm going to save it under this product name, product 1. And then I'm going to insert the block. So let me see, insert a new part in there, and I'm going to call this thing the block. Right click properties. There's the part name, or actually Catia calls it part number, block, and there is the instance name, block. Okay, let's make it. So to make it, double click on this line here, which is a single gear. You can see that. Double click, and on the convenient plane, on that vertical plane, I will sketch. Well, how about making a centered rectangle? Okay, and let me dimension these things accordingly. So it's going to be 10 by 4. So this is going to be 10 inches. It's going to be 10, and this is going to be 4. Okay, and exit. And I'm going to remember, I could have drawn two circles in here and then padded it so there would have been two holes, but I want to do it differently. Okay, so we are in part design. That's good. So let's pad it in both directions. Mirror extend by half an inch, 0.5 inches. There we are. On that face, I will sketch. The choice is yours how you want to do that. So I'm going to do it like this. Okay, so let's dimension this guy. First of all, I think the diameter is 1. If I'm not mistaken, diameter is 1. And then the distance from this point to that top line is also 1 inch. Okay, let's check it out. Yep, 1 inch. And then exit, and then pocket it all the way through. Okay, pocket. Oh, it didn't go all the way through because when I pocketed it, it had the dimension on it. So let me double click on it. We say all the way to the last. Good. Now I'm going to mirror this pocket with respect to that horizontal plane. Okay, so mirror, check it out. It's supposed to be this one, mirror. Read the bottom left corner. It says select a plane that you want to mirror. So first of all, let me do the following. Let me select the pocket and then mirror with respect to that horizontal plane. And we say, okay, good. Uh, we go all the way to the top level, click on the floppy disk, and it's going to put that block in the folder activity number 2, lab 8 activity 2. So the product was already saved there. And this way, if you go all the way to the top and click on the floppy, if you're not sure, it's your responsibility to use save management to make sure everything is in the place that you have to submit on your exams or your homework. Good. Now we're going to insert a new part in there. I always say no. Read that thing at least once probably. Right click properties, call it top pin, top pin, and top pin. Now remember, these two pins are identical, so it's up to you whether you want to create one of them and then use a copy of it. So basically copy and paste, or uh, save it and then use an uh, existing component. That's entirely up to you. I'll do the long way, which is not the efficient way. So I double clicked on the top pin, so that in part design on the vertical axis, on the vertical plane, I will sketch. And to do that, I project, instead of drawing a circle, I'm going to project this, exit. And I think the length of that was 3 inches. So I'm going to pad it in both directions, 1.5 inches in each direction, 1.5. So that's going to be a total length of 3 inches. And I'll do exactly the same thing at the bottom. So go all the way to the top, insert, new part, always say no, bottom pin, right click properties, bottom pin, and this is the bottom pin. This is actually part name, bottom pin. Okay, and then okay, let's go double click on it, and we're gonna go make it. So on that same vertical plane, I will sketch, project this thing one more time, the bottom curve one more time, bottom circle one more time. There we are. Exit, and then pad it, mirror extent, 1.5 inches in each direction. Okay, we go all the way to the top. Let's apply everything, but still to everything. So apply material. Because I selected the product, it's going, when you apply it to the product, it's going to put it on all the parts. If the parts were made of different material, then you have to do it one by one in the appropriate part design workbench. Or even in the product, but you have to be careful how it's done. Now, let me see. I was going to say that. Oh yeah. Right now, there are no assembly constraints, the constraints in the product design. So if I ever have to move this pin, it's going to stay in that move position. And that may or may not be acceptable to you. So in that case, you apply constraint. I'm going to do that in class, but I will not do it in this tutorial because I'm assuming that you were in the class and you saw what I was doing. Good, good. Uh, I have no plan to move these things, therefore that's okay. Uh, Now, oh, let's split this thing. So get the saw in the product design, product, or assembly design workbench. Assembly features, and there's a split here, and this split, see this split, and there are other things you can do in here, but I'm not interested in that. A split, you can select the entire assembly with uh, with a certain thing, and then say which one do you want to be affected. Now, if you click on it, nothing will happen. Notice that obviously the product is selected, but if you look at the bottom left corner, it says select the thing that you want to split it with. Well, I want to split it vertically, and it says, hey, all of these are affected. Are you sure you want them all? Yes. So notice that which side you want to keep, it doesn't matter to me. And I'm going to select it vertically by this other plane. So another split, this time by this vertical plane. And it says that, well, these are all affected. Are you sure all of them to be cut? Yes. And there we are. It doesn't matter which side we pick. And there we are. So this is the model that the assembly that we have to model for finite element analysis. Now, remember, this middle one is not a planar symmetry for the conditions that are given in this problem. So let's click on the floppy so that everything is saved again. Now we're going to go to generative structure analysis. Catia sees three parts and it measures them immediately. It sees not three parts, it sees three solid parts, solid object. Measures this, measures that, measures the bottom bit. Now, you can keep this the way it is, the elements the way it is. Now, these are too fine, this is too big, but I will keep it exactly like it is, okay? However, I will do a mesh refinement around the hole here and the bottom hole. I will do that. Now, to do the mesh refinement, I showed you in class how it's done. So you go to the model manager where the traffic light is, exactly like you did on the midterm. You click on it, it says, where do you want to do local mesh? Now, notice that nothing happens because read the bottom left corner of the window. It says select the mesh to be refined. Now, notice that we have three meshes. Which one do I want to refine? I don't want to refine the ones in the pin because they're already small. So here's the block. And then it says, okay, where do you want to refine? So let me go here. Let me hide this thing. And let me hide that. And you go and select these two faces because we want to make a refinement on this face and that face. Now the size, notice that already it decided based on this number that was sitting here from the previous maybe year, I don't know, or maybe before the midterm, it uses this size element. If that's happy, you're happy with it, keep it, otherwise make it bigger or smaller, whatever you want to do. Now, if you look at the mesh now, if you look at the mesh, right click mesh visualization, notice that, let me change the rendering here. Over here, we have gigantic elements, but around the hole, around the hole, on the solid, on the block, we have a finer mesh. Okay? It didn't do anything to this because I didn't select it for refinement. I only selected the mesh for the block and the appropriate places. Okay, we're gonna keep it like this. So, I mean, this basically these pins are overkill as far as the size goes, but I'll keep it. I'll keep it. Now deactivate this. Deactivate it. Good. The pins are still here, but they're in hiding. If you want, you can get them. I don't need them, but if you want, you can get them. Well, I need them for applying restraint and load, of course. Now, surface sliders. Anything that you cut and is a plane of symmetry is a surface slider. So this is a surface slider. This is a surface slider. This top piece is a surface slider. And here and here. And if you want to do them all at the same time, you might as well do it this face, side face, this half a quarter, half a circle, and that half a circle. These are all planes of symmetry. They were introduced because of the cuts that we made. Now, this bottom is clamped, so let's clamp this. Okay, you can see that. If you zoom in, you can see the clamp right there. You can see that. Now the top, this top is being pulled up. If it's being pulled up by some amount, first I have to make it 0, and that's the way it works in Catia. So in the direction Z, that side face, this side face, in the direction Z, 0. Rotations, remember, do not have a role in solid elements, tetrahedral element or octatetrahedral element. And now that I have this, I can go and change it. So you go under, this is the one that I just made 0 right there, this face, you see that? 0. And now I can go and say enforce displacement under load. Check it out. Here's the enforced displacement. It says which restraint is this restraint, by how much, in the direction Z by 0.01, right? 0.01 inches. Now, if you see any numbers here, these are from the last time that I ever used this enforced displacement. Unfortunately, these things go away. And if they're confusing you, just zero them out before you go. And there's a -2 degrees. Remember, we did problems like this where we had to rotate a beam by 2 degrees. These are coming from 3 or 4 weeks ago. We say, okay. And hopefully we didn't forget anything. Let's go and save our analysis file, save management. The analysis is right here. Save as in that same folder. I have to go find it again. Let's go here. It was called do not delete activities lab number 8, activity 2. There's no analysis here. That's why we don't see here anything. But let me see for a second. Can I say all of them in case? No, that's okay. I'm going to say okay and then okay. If you go to that folder, you see that there is a product, 3 parts, and the analysis. Actually, let's check it out. Oops. Let's check it out. So let's see now. Where is that thing? Do not delete. Activities number 8. There is a product 1. There's a block, top pin, bottom pin, and the analysis. And for the final exam, if you have an assembly, you have to give us all of these. Any one of them is missing, it's on you, and you didn't do your basically what you're supposed to. Okay, if you have a product, you're analyzing a product as an assembly, you have to give me the product and the parts in it and the analysis, all of them, please. Good. So let's go ahead and run it. If there are any issues, and there will be issues, I can assure you, just like in activity 1 I had issues, there will be issues. I'll show you why. It says factorized matrix computation, possibly restraints missing, etc. So if you know what the issue is, fix it. If you don't, let's actually try to see what the displacement, how does it look like? And look, actually the block goes through the pin because the pin and the block have no idea the other one exists. So this is why whenever you do assemblies, you have to create connections and appropriately define those connections. So let me deactivate this. All right. So what we want to do is we want to say that there is a connection between the face of this pin and the inside face of the hole, bottom hole. And the same thing with the top one. Face of this pin and the inside face of the top hole. These connections, once you define them, general analysis collection, then you're going to say these are contact. If you say these are fastened, that means that this whole thing, this whole object was machined like that or casted like that. I don't, in this problem, it says the pins were inserted. Okay, so you have to declare them as contact. So first of all, let's create the connections. Let's do it with the bottom one first. And for the second component, you hide the bottom one and select the face. So this is just a connection. It doesn't say what kind of a connection. And these are actually created here. This is the one that I just did. Let's do another one for the top one. And the order is not important, whether you select the pin first and the surface inside of the hole or the other way around. The order doesn't matter. Second component, let's hide this. There we are. So we created 2 connections. One is for the top, the other one for the bottom. And now we go to face-to-face connection, not the distance connection property, I want the here. I want face-face connection property. So you click on find out where the contact is. There's a contact here. We're going to be doing these other ones in future classes. Contact. Okay, so we'll select this one. You have to do them separately. It won't let you select. Yeah, it won't let you select uh, simultaneously. These numbers mean something, but for now we don't worry about it. Okay, and where's the other one? Another one for that bottom one. And notice that when you do these things, these appear in the tree, contact connection properties, and they appear in the properties also. If you want to delete, oh, not here, properties. If you want to delete anything, any of these, you cannot delete it from up here. You have to go to properties and delete it. For example, let me try to delete here. There is no delete. You can see that from the element. But you can go here and delete it, and it's going to be gone. Let me undo it to come back. I didn't want to delete it. I just wanted to show you that they cannot be deleted from up there. Okay, so before we had a problem, let's go ahead and run it now. Always save before you run, in case something happens, in case you have to shut down the computer, laptop, in case the computer crashes, and then we're going to run it. Last time it bombed out. This time it will go through. That's all right. It takes longer. These are contact problems. I'm using a very fine mesh. You can see that. So if you go to deformation, right click, activate, uh, change the scale. Make sure you reset the scale right here. Amplification magnitude. Click on it. Say default. Ah, there we are. You see that? So let's animate. Before it cut through it like butter, but here it won't do it. The pin will pull the block up. You can see that. Now, of course, this bottom pin, the end of it is faced. Okay, now, if you want to look at this displacement, obviously nothing very substantial is going to be shown there. Average ISO, we see now material shading. Now, notice that over here, we pull this thing by 0.01. The numbers there are a little bit bigger because when you pull this thing up, of course, it also goes sideways, okay? It also goes sideways. So this is the magnitude of the displacement, which is a little bit bigger than 0.01. By the way, if you want to see your elements here, let's go to uh, the rendering here. That down here, there's a question mark there. And just select it, and it's going to come up with the elements. Anything that you don't like, you can hide. So let's hide all these restraints. Okay, let's hide all the loads. Okay, let's hide all these elements that you may not want. Can I hide it? Yeah. And let's hide the connection. These are the connections. Let's hide the connections. Good. Now, look at the one Misa stress. Oh, there are these things. These are also, hide them. Okay. If you look at, by the way, if you zero in, you see that there's some weird stuff happening here. These are the contact elements that are created. And if you don't want to see them, you can hide those two, and those are probably okay. So if you double click on it, selection, just don't show me all the contact stuff. Just show me the mesh for octree block, octree pin, and octree other pin. Notice that it doesn't show you all that junk in the middle, which are internally needed for contact calculation. Now, if you want to see the von Mises stress, there we are. Say the block, if you want to just see the block, so just the block here and right there. Okay, when you think about it, that makes sense. When the pull is pulled out, when the pin is pulled up, it actually exerts a lot of pressure on this edge, and this is what happens. And the same thing with down here. Okay, good. One last thing I want to do is I want to know how much force is needed to pull this thing up. So you do the usual thing. You go to the bottom, right click, create resultant sensor, reaction sensor. Go and select that for example, pulling up, remember pulling it up? You had to go and create this right there, this restraint, for making it 0 first and then pulling it up. You click on that and you say update, and you're going to get uh, almost 3,000 pounds. Now, you might say, what is the answer needed if I have to write report testing in my exam? What is the force needed to create this displacement? Now you have to take this thing, okay, and you have to multiply it by, what do you say? You have to multiply this thing by, I want you to tell me what, by 4, okay? And the reason is that if you, it's going to be this times 4, because let me deactivate this. Okay, let's get the pins. Uh, Let me get the pins here, which are in hiding, just so that I can show it to you better. Okay, here's the situation. I'm going to change the rendering here so that you can see it better too. Good. So that restraint was only on this. Okay. So you have, it's how much force was needed to pull this quarter of a circle up. But there is also not quarters, half a circle up. But there is also the half a circle on this side that we did not model. But there is also the parts on the other side that we did not model. So that's why whatever is needed to pull this thing up, you have to multiply it by 4 to get the final answer, full mark on that particular question. All right, guys, good luck. This is it for activity number 2.